Today's objective is to use a multiplier or divisor to create equivalent fractions. Now we've learned a little bit about equivalent fractions, but let's talk a little bit more about them. Equivalent fractions are fractions that represent the same value but have different numbers. I like to think of the word equivalent and just think of the word equal. So basically they have equal values, even though they look different. What did we learn yesterday about fractions? Yesterday we talked about several vocabulary words. We talked about the word fraction. And when we talked about fraction, we noticed different representations of fractions. You could do it as a circle or kind of a pie. You could do it as a bar where you're shading in pieces of a bar. You could even do it as just groups or an array where you're shading in a couple of those. Anytime you have a division problem, what you really have is a fraction. A fraction represents a part of the whole. And that part is what we call the numerator, which is down here, and the whole is what we call the denominator. So on the bottom of a fraction, you have a denominator, which represents how many total there are. And then on the top, you have a numerator, which shows how many a person has. So the top number, the numerator, shows what part you have. The bottom shows how many there are in all. We also have talked about unit fractions. Unit fractions are simply fractions that have 1 on the top. It's the smallest unit that you can get to if you divide that into equal parts. So for example, on this one, we've divided into 3. The unit fraction would be 1/3. We've also talked about equivalent fractions. Equivalent fractions are fractions that look different, but they have the same value. Here are just a few more of the vocabulary words that we have covered. We talked yesterday about factors. It's a review of a concept that you learned last year. Factors of 12. We get those by deciding which numbers we can multiply to get 12. So factors are numbers that you multiply to get another number. In this case, 1 times 12 is 12. 2 times 6 is 12. 3 times 4 is 12. And then we've gotten to the end of those factors. We also have talked about multiples. Multiples are when you multiply a whole number times a number. So in this case, you'll notice all the factors have to be smaller than 12 or smaller. All the multiples have to be higher than 12 because you're multiplying 12 by another whole number. 12 times 1 is 12, 12 times 2, 24, 12 times 3, 36, 12 times 4, 48, 12 times 5, 60, and so on. You could have infinitely many multiples of a number, but you only have a certain number of factors of a number. Today we're adding a new vocabulary word in. It's called multiplier or divisor. The multiplier or divisor is simply the number that you multiply both the top and the bottom of a fraction by in order to get another equivalent fraction. So in this case, 1/4 is equivalent to 2/8. In order to find that, I had to multiply 1 times 2 to get 2 and 4 times 2 to get 8, and that gives me an equivalent fraction. I can do the same thing with a divisor if I divide both the top and the bottom, or the numerator and the denominator. 24 divided by 4 is 6. 32 divided by 4 is 8. It is very important, however, that your divisor or multiplier is the same number on the top and bottom. That means you must always multiply or divide the same on the top, or the numerator, and the bottom, the denominator, in order to get an equivalent fraction. Let's just talk about equivalent fractions a little bit more. Um, there are certain ways that you can do equivalent fractions. One, you can divide something, for example, this into 2 and have 1/2 over here, or you can divide it into 4 and have 2/4. So here I'd have 1/2 on this one. Oh. And here I might have, and that would be this shaded area right here. And here I'd have 2/4. Okay. Or I might have something like this, where I shade in this area right here. Ooh, that's tricky to do. And I have 1/3, or I might shade in the same area, and in this case, I've got 2/6. Another way to think about it is a number line, which we've used in class for some of our problems. On this number line here, I've got 1, 2, 3, 4, 5, 6, 7, 8 parts. So this is an eighth. This middle one would represent half of that, which is 4/8. I should have made that a little bit bigger. This would represent 8/8. If I'm looking for equivalent fractions here, it's very easy to see, okay, so I'd have 1/8, 2/8. Here I'd have 2/8. And here I've divided into 4 pieces, so I've got 1, 2, 3, 4. This one would be, let me get a different color for that for a second. This right here, since it's in fourths, would be 1/4. Okay. Now we've learned that a multiplier is a number that the numerator and denominator are multiplied by to get an equivalent fraction. What this means is this: if I have any fraction, let's say I have 3/5, and I multiply the top and the bottom by the same thing, I will get an equivalent fraction. So 3 times 2 on the top, 3 times 2 is 6, 5 times 2 is 10. And I know then that 3/5 and 6/10 are equivalent fractions. The multiplier in this case is simply 2. So the multiplier is 2. Now, why is it important to have the numerator and denominator multiplied by the same multiplier? It's basically this. We know that anything, any number times 1 is the same number. We also know that anything on top, whether it's 2/2 or 317/317, we know that that also is equal to 1. So what I'm really doing is just multiplying 3/5 times 1 to get something that's equal to 3/5. But it's very important to do it on the top and the bottom, or I'm not multiplying it times one whole thing. So here's a class pizza question. If I have 2/5 of a pizza for girls and 3/5 of a pizza for boys, what does each denominator represent? The denominator represents how many total slices of pizza I have. The denominator in this case is 5. So it's how many total slices of pizza. What does each numerator represent? Well, it represents individual slices, 2 slices for girls and 3 slices for boys. Who gets more slices? In this fictional problem, the boys do. Who gets larger slices? A lot of people want to say girls do or boys do, but that's wrong. Remember that in a fraction, they have to be equal parts. If you have equal size slices, nobody gets larger slices. Everyone gets the same size slice. Who gets more pizza in all? In this fictional problem again, the boys do. Now we've used number lines to look at equivalent fractions before. In this case, we have it divided into thirds: 0/3, 3/3, 1/3, sorry, 2/3, and 3/3. This time it's divided into 6. So I'd have 1/6, 2/6, 3/6, 4/6, and 5/6. If I'm looking for something equivalent to 2/3, here I'd have 4/6, and I can just use the number line to find that. 4/6. But it's much easier if we can do it by using a multiplier. We know that we have to multiply the top and bottom, the numerator and denominator, by the same thing. How many times does 3 times blank equal 6? 3 times 2 equals 6. Since I have to do the same thing to the top and the bottom, I'm going to multiply the top times the bottom. 2 times 2 is 4. So that's an easy way to get an equivalent fraction for 2/3 is 4/6. Same thing down here, 2/3 3 times 3 is 9. 2 times 3 is 6. Another equivalent fraction would be 6/9. 3 times 4 is 12. 2 times 4 is 8. And the multiplier is 4. Here's a real-world problem that might help us out. Henry needs to make 2/3 of his free throws in order to make the basketball team. If he throws 12 times, how many baskets does he need? So we know 2/3 of his free throws have to go in if he wants to make that basketball team. And we need to know if he has 12 chances, so 12 total throws, how many have to go in the basket? In order to get that, 3 times blank is 12. 3 times 4 is 12. We have to do the same thing to the top and bottom. 2 times 4 is 8. If he throws 9 times, how many baskets does he need? So again, if the requirement is 2/3 to get onto that basketball team, and he's only going to get to throw 9 times, how many does he need? 3 times 3 is 9. And again, 2 times 3 is 6. Here is a common error that lots of people make. Here's Puzzled Penguin. Dear math students, I tried to find a fraction equivalent to 5/6. I multiplied the denominator by 2 to make a smaller unit fractions. This can't be right because 5/6 is almost 1 and 5/12 is less than a half. Why doesn't my method work? What did he forget to do? He forgot to multiply both the numerator and denominator by the same number. The multiplier or divisor must be used both on the numerator and the denominator. So it should be that he multiplied both the top and the bottom. Then his answer would be 10/12 instead of 5/12. And that is equivalent to 5/6. Okay, so hopefully you remember our objective today, that you can use a multiplier or divisor to create equivalent fractions.